Every time someone uses ChatGPT, Gemini, Claude, or another AI system, something remarkable happens behind the scenes. Within seconds, billions of calculations are performed to generate a single response. Those calculations require an extraordinary amount of computing power, and at the heart of that process is one company: NVIDIA. Just a few years ago, NVIDIA was best known for making graphics cards used by gamers. Today, it has become one of the most influential companies on the planet, powering everything from artificial intelligence and robotics to self-driving cars and scientific research. But here's the surprising part. NVIDIA didn't set out to become the company leading the AI revolution. Its biggest breakthrough came from solving a completely different problem. So how did a business focused on video games become one of the most valuable companies in history? The answer begins with a tiny piece of hardware that changed computing forever. For decades, almost every computer relied on a central processing unit, or CPU. Think of the CPU as the brain of a computer. It's incredibly good at handling tasks one after another, making it perfect for everyday computing like browsing the internet, writing documents, or running software. But artificial intelligence works very differently. Training an AI model doesn't involve solving one problem at a time. It involves performing billions and sometimes trillions of calculations simultaneously. That kind of workload quickly overwhelms a traditional CPU. This is where NVIDIA's technology became invaluable. Instead of designing processors that focused on one task at a time, NVIDIA built graphics processing units, better known as GPUs. Originally, GPUs were created to render realistic graphics in video games. They could process thousands of operations at the same time, making games look smoother and more detailed. For years, that seemed like a niche advantage for gamers. Then researchers made an unexpected discovery. The same architecture that made GPUs perfect for graphics also made them incredibly effective at training artificial intelligence. Instead of spending weeks or months processing complex AI workloads on traditional processors, researchers could dramatically reduce training times by using thousands of GPUs working together. Almost overnight, NVIDIA's gaming hardware became the foundation of modern artificial intelligence. What started as a product for gamers had become the engine powering one of the biggest technological revolutions in history. And the demand was only beginning. As artificial intelligence advanced, demand for NVIDIA's processors exploded. The world's biggest technology companies suddenly needed tens of thousands of GPUs to train increasingly powerful AI models. Companies like Microsoft, Google, Meta, Amazon, and OpenAI weren't just buying computer chips anymore. They were building entire AI supercomputers around NVIDIA's hardware. A single AI data center can contain tens of thousands of GPUs working together, performing calculations at a scale that would have been almost unimaginable just a decade ago. Every new generation of AI models requires more computing power than the one before it. Larger models need more processors. More processors need more electricity. And more electricity requires more infrastructure. That's why NVIDIA isn't simply selling chips. It's helping shape the future of artificial intelligence. The company's latest AI processors are designed specifically for machine learning, capable of performing massive numbers of calculations simultaneously while consuming less power than previous generations. But NVIDIA's real advantage isn't just its hardware, it's the ecosystem built around it. For years, NVIDIA invested heavily in software that allows developers to unlock the full performance of its GPUs. As more researchers and engineers adopted these tools, switching to another platform became increasingly difficult. By the time artificial intelligence entered the mainstream, NVIDIA had spent years building an ecosystem that many competitors struggled to match. This created a powerful cycle. More developers chose NVIDIA. More software was built for NVIDIA. More companies invested in NVIDIA hardware, which encouraged even more developers to build around its platform. That network effect helped transform NVIDIA from a successful semiconductor company into one of the most strategically important businesses in the AI industry. Today, governments, cloud providers, universities, and research institutions all compete for access to advanced AI chips. In some cases, demand has become so intense that organizations wait months before receiving new hardware. The race for artificial intelligence has quietly become a race for computing power. And in that race, NVIDIA sits at the center. But history has shown that no company remains unchallenged forever. As demand continues to grow, competitors are investing billions to reduce the world's dependence on a single supplier. The next chapter of the AI revolution may not be about who builds the smartest artificial intelligence. It may be about who builds the hardware that powers it. So, what happens next? NVIDIA may be leading the AI revolution today, but history suggests that every technology leader eventually faces competition. The question isn't whether challengers will emerge, it's who will succeed first. AMD is investing heavily in AI accelerators designed to compete with NVIDIA's most advanced chips. Intel is rebuilding its position in artificial intelligence, while companies like Google, Amazon, and Microsoft are designing custom chips tailored to their own AI systems. The goal is simple: reduce costs, increase performance, and avoid relying on a single supplier for the technology driving the future of artificial intelligence. Governments are also becoming more involved. Advanced AI chips are no longer viewed as ordinary computer components. They're becoming strategic assets. The ability to design, manufacture, and secure access to these processors is increasingly seen as a matter of economic competitiveness and national security. That's one reason why countries around the world are investing billions into semiconductor manufacturing and strengthening their domestic chip industries. Artificial intelligence has transformed computer chips into one of the world's most valuable resources. But perhaps the biggest lesson isn't about NVIDIA itself. It's about recognizing where technological revolutions create value. When most people first heard about artificial intelligence, they focused on chatbots, image generators, and futuristic robots. Very few people were paying attention to the companies quietly building the hardware behind those breakthroughs. NVIDIA understood something long before the rest of the world did. The future of AI wouldn't just depend on smarter software. It would depend on having enough computing power to run it. That's exactly why a company that once built graphics cards for gamers became one of the most valuable businesses in history. And the story isn't over. Artificial intelligence is still in its early stages. New models will require more computing power. New industries will adopt AI. New competitors will enter the market. And billions of pounds will continue flowing into the infrastructure that makes it all possible. Whether NVIDIA remains the dominant force or shares that position with new rivals, one thing seems increasingly clear. The demand for AI computing is only just beginning. And that's what makes this story far bigger than a single company. It's the story of how one unexpected innovation helped lay the foundation for the next era of technology. If you enjoyed this documentary and want to understand the technology, business, and investment trends shaping tomorrow's world, subscribe to Future Capital. Every week, we go beyond the headlines to explore the ideas, industries, and companies building the future. Thank you for watching, and I'll see you in the next documentary.